Hello, beginning linear algebra students. Section 2.3 of the book Linear Algebra with Applications, which is an open educational resource, and I'll put the link below the video, had some interesting definitions I wanted to point out, especially since trace and idempotent matrices were in the homework, and these definitions might be overlooked. So, first definition, composition and composite functions. We'll have a little sign with a little, it's a capital T and a little teeny circle and an S. And what I tell all of my algebra students is think of that little circle, that composition circle, as the word of. So it's take the function of a function. So basically, you figure out whatever the inside function is, s of x, see s of x, then you want t of s of x. So that's how composite and composition work. Blocks are really useful. Desmos has a limit of a 6 by 6 matrix. And so if I have A equals this and B equals that, then when I do multiply the two together, I can just put x, which is this top part, into my answer, and then I can figure out what p, x, and q, y are. So let me show you in Desmos. Okay, so I had to call this part A, and this is B, this is C, and D. So I need to multiply A and B together, and then add, trying to move Desmos over, C and D. So, enter. So I need AB plus CD. And so this is how blocks can really help if you've got a limited amount of room you can use for multiplication. I'm also going to use it with the idempotent, but let's get in trace. Okay, trace is a definition that's coming from your homework. It basically means, let's take the diagonal, so it means we have to have a square matrix, take the diagonal and just add them all together. So let me go to Desmos and show you. Okay, so yeah, just making sure I put it in correctly. So I'm going to hit enter. Okay, enter. Then I can say trace of, in this case, is E. And I get -5. Now, if I had tried something like D, enter trace of D, the warning says you can only do this with a square matrix. So if I come back to the slideshow, and let's say I have this matrix, it won't work. I can't find a trace because which diagonal do I use? Okay, idempotent also comes from the homework, and it basically says it's an idempotent matrix if you square it and you still get the same thing. And this was one example right here. And back to Desmos. Okay, so here's my matrix. It's actually F, but if I do F squared, you notice that didn't even change. If I square it again, I can square it as many times as I want, and it doesn't change. It's idempotent. Okay, pulling up the matrix B, and again, we're not looking at a square matrix, but I can use an example on page 74. It says, why don't we use blocks? And we'll just put an identity matrix on top of it and then make it square by filling everything else in with zeros. So, one more. Okay, notice I put I2. My identity is a 2 by 2. Back to Desmos. Okay, just trying to double check. 2, 1, -3, 7. This is where I get in trouble, is messing up on one of the numbers. So enter, and if I square it, I don't change a thing. It's idempotent. Now, I don't necessarily have to leave it the identity matrix as a 2 by 2. I can move it down as a 4 by 4. Now you notice this other section that's kind of kitty corner, it stays zeros, but next to it I can always get an idempotent. So pulling up Desmos, and I discovered something really cool. I can just change it, zeros and zeros, which it doesn't like. It just says, well, it's a zero matrix. But let me change this to a 1 and a 1 and a 1 and a 1. So you see we're back to G equals G squared. Idempotent.